Rwanda 2010 Demographic and Health Survey, or DHS data, summarized and mapped by district. This is the same Rwanda 2010 DHS data mapped by an NGO's catchment area, and us using that data for program impact evaluation. How are we doing this? Let me show you in this short tutorial how to summarize DHS data by non-DHS regions. Starting in the late 1990s, the Measure DHS project started collecting GPS coordinates of all sampled communities in most of the DHS surveys. These coordinates are geographically displaced to protect the identities of survey respondents. In urban communities, these coordinates are randomly displaced up to 2 kilometers in any direction, and in rural communities, displacement occurs up to 5 kilometers, with 1 in every 100 coordinates displaced up to 10 kilometers. This means that you should absolutely not use these GPS coordinates to aggregate DHS data at very local levels, or to calculate local distances. These GPS coordinates are intended only to be reaggregating DHS data to intermediate and larger geographic units. We are going to download 3 datasets and combine them. First, we map the GPS coordinates, then join other spatial data to the GPS coordinates based on spatial location. Using the GPS coordinate IDs in the attribute table, we will join all of this spatial data back to the original dataset to be used for summary statistics and analysis. Are you ready? First, download the DHS survey data and related cluster coordinates from measuredhs.com. Under the Data tab, select Download Datasets. If you type Ctrl F, you can search by country. Here are all the surveys for Rwanda. If you click on the survey name, you will find all DHS publications with that survey data, plus key characteristics about the survey such as number of respondents and type of questions that were asked. To download the survey data itself, go back to the dataset list and select the Data Available link under the Survey Dataset column. Since we haven't logged in yet, none of the survey data are downloadable. If you are a new user, you can register with an email and request access to the dataset, and if you're already registered, just log in. I have requested DHS data already for a number of projects, so anytime I'm logged into the DHS website, I can open my project and download data for approved countries. Now that I'm logged in, the DHS survey datasets, related GPS coordinates, and any approved biometric HIV or malaria datasets are now downloadable.
Let's download the individual women's recode file, formatted for Stata, so I can show you how to summarize DHS data in Stata, and the GPS coordinates. We have to unzip these files before we can use them in either Stata or ArcGIS. I'm now going to map the GPS coordinates in ArcGIS so I can link them to other spatial data. My other spatial data in this case is a modified file of districts with an NGO service coverage area covering 1.5 districts in southeast Rwanda. I add the DHS GPS coordinates provided as a shapefile. Now the goal is to link the names of the modified district boundaries to the DHS GPS coordinates, and I do this in ArcGIS with a spatial join. I select the Is Closest To option in case the GPS coordinates were mapped using a different boundary file and a coordinate technically falls outside the boundaries that I'm using. And I save the join data into a new shapefile. When I open that attribute table, you see it contains the original GPS attributes from the Measure DHS and the attributes of the district file. And there are the coordinates that fall in our catchment area. With the attribute table open, export the table to a text file, because Stata does not recognize a DBF file, which is what a shapefile stores attribute data in. Now let's open Stata. We will import the women's Stata dataset from the DHS website and the attribute table of the new shapefile, which we just saved as a text file, and merge them based on GPS coordinate ID, which is also called a cluster ID or a primary sampling unit ID. This allows us to map any DHS indicator by our own geographic units. So for example, let's map % of pregnant women who received the recommended 4 or more antenatal visits. Clear cleans out the memory after the first run. I create a global macro with my project folder location so I don't have to type this bit repeatedly, and it's easy to change if I run this program on a new computer. To import and save the GPS coordinates in Stata, type InSheet using and provide the path and name of the text file. When we run that, we see our GPS coordinates with the district information successfully imported into Stata. Good job. This variable, DHS clust, is the GPS coordinate ID. I recode it to match the DHS primary sampling unit ID, V021, to facilitate the merge. I sort the file and save it. Now we open the individual recode file and make our lives easier by keeping only those variables that are relevant to our analysis. Use calls the Stata file. We keep all of the variables between case ID and V025 because these specify the study design and we'll need them later to adjust our estimates. To figure out which variable has antenatal care visit data, I consult the map file which was included with the original individual recode file. I see that variable M14 has the number of antenatal care visits for a woman's last pregnancy. I recode this into a binary variable that I wish to analyze and map. 0 is for 0 to 3 visits, and 1 is for 4 or more visits. I call this variable antenatal 4. I also convert the sampling weight variable, V005, into a decimal value by dividing by 1 million. Whoops, and don't forget to label this new variable. Summarizing the frequencies of the new binary variable with a tab or tabulate statement helps us to check for mistakes. Let's sort by primary sampling unit, V021, and save the new file. We now have two data sets, one with antenatal visit data and the other with spatial data. Both share a common variable, which is primary sampling unit ID, and it's time to merge them. This is a many-to-one or M:1 merge because there are many women in each primary sampling unit. The merge output shows that all of the records in both files matched. We drop the underscore merge variable that was created automatically during the merge and save this new file. And here is where the magic happens. We now have a file with DHS antenatal care data classified by the modified district that we created. After we specify the DHS sample design with a survey set statement including the probability weight, primary sampling unit, and strata, we can tabulate our variable antenatal 4 by modified district name. Percent displays proportions as percentiles, and row gives the summary statistic by district. Pretty cool, right? These numbers are what we need to evaluate impact of our intervention in Southeast Rwanda. Let's say we want to map these numbers. There are likely easier ways to export a CSV or text file. I just copy these numbers into Excel and use the text-to-column function to create a CSV file, and use the same district names as the shapefile. I add the CSV file to ArcGIS and join it back to my shapefile in a table join based on that modified district name. And there we have it, DHS data summarized by non-DHS regions and ready to analyze or map. So let's take this data and map it in red with district labels, with a landscape orientation, with a proper title, north arrow, scale bar, and source. Let's add a legend. This red is too pink. How about orange? I'll enter a custom color palette that's been shown by colorbrewer.com to have a good screen and print contrast. And with a little more fiddling, we have a lovely map of antenatal care coverage in our catchment area and other districts. Thanks for watching!